So does everybody have a link to the agenda? I'm gonna put it in the notes. Hey, Paul, glad you're here.
Yay.
So before we get into the Lattice Grid presentation and discussion, I just wanted to remind everyone that we're having a hackathon at Cornell in October. And I'm going to go real quick. I'm going to go to the page. And what you'll see is at the top of this wiki page, and I'll put the wiki page is in the meeting notes. There's a register button, and if you click register, it'll take you to a survey that you fill out real quick just to collect some information. Just let us know logistically how many people are coming. Some of the proposed topics are the VIVO ISF ontology. I know Melissa Hendel and some of the people from OHSU, I believe Shahem Assad will be there, and there will be some discussion and work on the ontology. John Ferrer will also be there doing some work on the harvester. Ted Lawless will be there and talking about how to deliver VIVO data to apps. Looks like Huda Khan is going to be working about adding a new vocabulary service to VIVO. There might be some talk on data visualizations. I know that the guys from Colorado are working on trying to form a working group or try to get up at least a interest group to talk about the topic of replacing permanent visualizations in VIVO with D3 visualizations. And then I know Jim Blake will be there trying to get someone to see if they're interested in working on the core code for VIVO or possibly becoming a VIVO core code committer. I know Jim has been doing work on the API for VIVO, and I know that Alexander Rademacher from Brazil has been testing that API. He sent an email to the list. I don't know if everybody saw it, but he was trying to pack quite a few triples in using the API, and I guess he figured out there's a max number per 24 hours, and it's about 384,000. So we'll see how that plays out.
Ooh.
Any questions about the hackathon, or any ideas on topics, or Ted? Did you have anything to say about the hackathon that I forgot?
Other than what you said, I know Alex is planning on devoting time on the October 2nd implementation call that starts at 1 p.m. To helping people or talking about getting if you're coming to the hackathon, getting set up so that you can be productive while you're there.
Well, fantastic.
This is Shahem.
Hey, Shaham, go ahead.
Hey, hi. I came in a couple minutes late, so I missed the first item, VIVO ISF ontology. Were there any specific plans so I could prepare for that? Because I'm attending, and I probably could help in that area more than the others.
I said that you were going to give everybody a hands-on tour of the ontology.
Yes, and I'm looking forward to that.
Okay.
I think the goal, Shaham. Well, actually, I was just going to mention. So I don't think we're going to be ready for the sort of deep dive on tutorials and training, but I think that some of the folks that are coming to the hackathon are more skilled than many of the other peoples that we aim to have contribute in the long term. So my hope was that actually things like what Huda is planning on doing would be included as part of sort of the ontology scope of what would be done. Although I also would think it would be good for a lot of people to get kind of a tour of where things are at.
Actually, I was just being facetious, Shaham. What I'm hoping is that people are going to come and you'll be able to help us. So, for example, I'm hoping to catch you, and I've got some geospatial data, some latitude and longitude attached to data, and I want to get your opinion on how it should be modeled in VIVO. So
okay. So I'm trying to migrate our ontology content to GitHub. I should have that done before the hackathon. I'll have a few wiki pages to explain how to work with that. I'm not sure how familiar people are with Git or not. So I think it would help if people at least have Git installed on their machines if they want to do anything.
Well, at the hackathon in Durham in March, we had quite a few people that are also on the call today, and we had them sign up for GitHub accounts, and we did quite a bit of training with Git. I think Violetta knows how to use Git now, right, Violetta?
Yes, I did some push to the TAMU Texas A&M website. I mean Git page.
Okay,
Sweet.
so
I
that
can
shouldn't
do
be a
it.
major.
Is there anything that one needs to do besides to sign up and have a GitHub account?
No, that's on the web. Anyone could sign up and
Yeah,
give your
okay.
account. But on your
Okay.
local machine, you have to have some kind of tool also to work with Git repositories to check out and view and so forth.
Okay, thank you.
As long as you have some tool, whether it's graphical tool or command line, so create an account, create a empty fake repository under your account, and then from your machine, try to check it out onto your machine, put a fake file on there, and commit it back. If all that goes well, then you should not have a problem working with any Git repository,
Okay,
whether it's
thank-
GitHub or somewhere else.
So one of the things
Okay.
that you may want to look at, and I'm going to put the link in the notes here for everyone that doesn't want to ask questions, but Ted has done a great job of putting together what's called a VIVO Vagrant, and this is a virtual machine with VIVO installed. And he's also got great instructions. And we recommend that if people want to play with VIVO and have a test VIVO to play with, that they replicate and install that following Ted's instructions before they come to the hackathon. And so there's also a couple of tutorials that he linked to, one for Windows, one for Mac, on how to get some of the GitHub clients.
Yeah, those are links to GitHub has a Windows and Mac application that will install Git on your machine. That's a good way to get up and running with Git. So that's something we can recommend to people coming to work on the ontology.
Great, thanks for doing that, Ted.
So for that session, I'm not sure how much time it will have, but other than
They're not
being
exactly
comfortable,
they're not exactly sessions. These are proposed topics. So there'll be an introductory session, and then
Okay.
we'll go around and introduce each other, and then we'll have everyone form small groups. So the idea
Okay.
would be that there would be people interested in working on the ontology specifically or data modeling in particular would form a group with you.
Okay.
And
Sounds
then,
good.
Yeah, and I think already that one with Huda would fall under that category.
yeah,
So maybe you can kind of merge those two.
Okay. Are there projectors or some kind of, or should we just rely on screen sharing like through some other system or?
logistically, I don't know for sure. I know there's going to be separate spaces. I'm pretty sure for us to have the different groups break down and go down into their separate groups.
Different groups. Okay.
And then the only formal other time is the ending time where we're going to have each group give a small 5-slide presentation of their work, what they've done.
Okay.
Chris, I'll pass on the question to John about projectors.
Okay, thank you, Jim.
Yep.
All right, if there's no other questions, I'm going to show you one of my favorite cool things I found recently. This is all
I saw it.
this is all HTML5, by the way, and WebGL. Let me
This is
refresh.
very cool, Chris.
And so Nick Bennick at Harvard. So it actually, my fluid ran out, so you can see it'll sit there and spin for a while. I call it my daily productivity killer. So if any of you are old enough to remember lava lamps, this is the kind of
Do I have to admit to that?
I didn't say like speak out, Violetta and Lane. So on that note, Paul, if you're ready, I'll give you presenter.
Sure. How do I do that?
I'm going to give it to you. A button should pop up on your screen, and it should
All right.
say, make me the presenter.
Waiting for the button.
There we go.
Maybe it's in the show my screen. All right. Hi all. I just got an email saying that the thing that I sent out to the VIVO ontology group was too large. Did anybody get the HTML attachment that I sent that was the
I did.
basic? Oh, you did?
Yes.
Okay, good. Somebody did. Other people, if you have, great. If not, I'll just probably just take everything and put it into the Google Doc.
I'll put it in there for you, Paul, if you want.
That's great. It just looked very ugly. So, anyway, so hi, welcome to Data Visualizations in Lattice Grid. I'm going to give you a quick overview of Lattice Grid. I'm guessing most people haven't really looked at it much. If you were at the last meeting on data visualizations, we were up there in the number of actual visualizations we had. That was kind of cool, and that's probably why we were asked to come today. I'll show you some of the things we have, the libraries we use, the data that we have access to, and then just quickly how we go and actually create these things. How do we choose the design? Basically, we see something elsewhere and says, hey, that looks nice. Let's see if we can do it. Google for the example, and hope for a tutorial. See if we can do it, and finally I'll tell you what we've learned. All right, so first, this was the link to Lattice Grid. I'm going to be just clicking on a bunch of links. If I go too fast or things don't show up, just let me know. Lattice Grid, open source networking tool that uses a lot of PubMed data to show interactions between our investigators and their work. It is completely open source. It is available here at GitHub under Nubic Lattice Grid. And if anybody ever wants to help setting it up, give me a call. It's not too difficult, but there are a lot of steps in getting your data in there. Here is our active production version of it. We have our list of our publications, most recent, Mesh Cloud, update it often. And we have this at many different institutions. Here at Northwestern, we have two separate ones, one for the Feinberg School of Medicine and one also for our Comprehensive Cancer Center. Some of the things that we have. We have them spaced in by focus, the investigator or the organizational unit. For instance, this is Warren's page. Warren is the man who created Lattice Grid in the first place. He's on loan right now to the NIH for us at CBITS or something like that. Anyway, so here we have a bunch of information that we get from about our faculty. His publications we get from PubMed, and then we do some associations on those. Our visualizations are here at the top of the page, and I will be going through each one of these just to show you kind of the array of stuff and how we have partitioned it. So first we have here is a radial graph. We use this as an evaluation version of Fusion charts. This is the only Fusion chart thing we have because this is the thing we can do with the evaluation version. And as you can see, this is Warren's publications with all of his co-authors. We also use a tool called GraphViz to create also a co-authorship graph similar to the radial, but with different things, and they have different outputs for with GraphViz. Another GraphViz shows our investigator wheel graph, which is also another. These are the people that we have worked with, and you can see with whom I've worked with and with whom everybody else has worked with. So you can get a 2, 3, 4 degree separation of people who have worked with, written with Warren. This is also GraphViz showing people that have associative mesh terms on their publications.
Cool.
So there's that one. We also have, we use something called Cytoscape. We actually are using the Cytoscape web version. They've since moved to a Cytoscape JavaScript version. This has a Flash installer that does this. Wait, is that the right one? Oh, no, that one's just, sorry. This is a D3 one. This is just a JavaScript chord graph. Sorry, it's under the same path as Cytoscape. Here's the Cytoscape graph that I was mentioning earlier, another radial graph, but here it's in the Flash. We also, this is, we had information not just through publications, but also through awards associations. Whoa, sorry. Oh, sorry, I need to be on the VPN here. Sorry. We don't have, we, oh, geez. Ah. Well, maybe I am going to have some of my presentation not be showing you at all. Okay, so we also disallow access to certain information based on IP address. Gosh, okay, so that kills a little bit. But so we have associations made through awards and made through studies as well. And maybe the studies is actually available publicly. I'm not entirely. Nope. Also disallowed. So obviously the show all is also going to be disallowed. Very good. And also, finally, we have this Wordle, which is from Warren's publications. These are the items that are most popular. I'm sure you folks have seen these things before. So let me close a couple of these windows and get back. We also have the same thing through organizational unit. So instead of having Warren being the center of the associations, we also can do this through, here are all the members of all the publications through preventive medicine, one of the departments here at the Feinberg School of Medicine. So you can see a co-authorship graph through for the department as well. And then, of course, I can go through these things and show you again the same graph viz, but through associated for the department. I switched departments at this point because of the size of some of these things, that the amount of data that we have doesn't render very well and keeps the user experience really well, they're waiting for something to load because some of these things can get pretty large. This is organization of organization relationship between preventative medicine and all the other departments here at the university. Yes, it's fun to make something like this, but I don't consider it very pretty to look at. And some chord diagrams and things like that. I'll show you the chord diagram. These are all the investigators here at the in preventative medicine, very similar to the chord graph that you saw with Warren earlier. But here it's nice to see folks that are newer to the university versus folks who have been here for a while, and get some information about this. So the libraries that we use, if you notice the URLs in my and something that I misspoke earlier about Cytoscape and D3, what we started doing was having each different URL having a different library of sorts. So in our graphs controller here, and at this point I'm going to be going into our code and having links to GitHub. So in our graphs controller, we use fusion charts. This is a simple, as you notice, we only had one visualization for that, so it's a much smaller file. And this is a link to fusion charts. So we never licensed. So it was something that we tried and found that we could do elsewhere. Graph Viz controller also has our Graph Viz things. We have our certain configurations and certain generators that we set for these things. And notice the caches page, which will be coming up a whole lot. So here's Graph Viz is one of the libraries that we used. If you are interested in visualizations, they're hiring, apparently. And then we use also, I failed to mention that LatticeGrid is a Ruby on Rails application that actually started in version Rails version 1.8 or something like that. And so it's been around a while. And so we use, so it's in Ruby. So we have certain Ruby interfaces to these graphing tools, which are available to us, which is really nice. And the cytoscape controllers was one I'm going to be actually digging most into because of the pattern that is used in this one. So our cytoscape controller, again, is probably our largest one. Notice how we have a number of caches here and certain configuration and generator files that use in order to manipulate data and get these things working properly. When we started with this, we used Cytoscape Web, as I had mentioned. It is still usable and available, but the more recent thing is Cytoscape.js, and we'll start looking into moving some of these maybe, or just playing around with other this new library. We also started with Mike Bostock's ProtoViz library. ProtoViz was a lot, has been moved since to D3.js, and so we have some of those as well. And here you have seen this page before. All right, so the data that we have, this is the stuff that we have. So we get this from various external data sources. The investigators investigators and organizational units we get from the Feinberg School of Medicine faculty database. We're lucky enough to have an open connection to several of these tables. The publication or abstract information comes from PubMed through BioRuby. Proposals, and these are also awards, comes from Sharon. I don't know exactly where she gets the data. We just get it from her. And then we have the study information, which comes through our IRB via a tool called eNotice that has been it's a mandatory here for us to use at for clinical studies at the university. So this is the raw data that we get from these data sources. We also have several of these association models, and what I call these things are things that we, after we get the raw data from these external data sources, this is data massaged by the application to create these associations so that we have an easy and quicker response of what these, who worked with whom, who worked on the, which investigators worked on the abstract or publication, to which organizational unit have they, are they associated, with whom do they work, again, proposal, who's on the award, who is on the study. We also associate publications with the organizational unit. And then the word frequency, this is the kind of an offshoot one for just a model basically only used for the Wordle. So we find a number of words for the investigators and parse these. So now that we have some visualizations and some data, well, let's see how this all comes together. Give me 1 second, I'm just going to close a bunch of these things. We'll get back to all of these wonderful pictures, so useful in things like grant applications and whatnot. and just to see stuff. It's fun. Okay, so our process. So let's, I'm going to just look at the cytoscape radial graph. Remember our process before was, hey, that looks cool, can we do it? So we saw the cytoscape web flash thing. So, and this takes care of a lot of the changes of the way that the graph is displayed. So for us, we just need to make certain that this is all set up properly and get the data great. So again, remember I said let's go and Google that and search for a tutorial. And hey, yay, this one we love because we can do that. So here, this is a quick tutorial on cytoscape web. And as you can see, the most important parts are, here's our data and our div of how this put together. And of course, here are options, which you'll see very soon, and our code. So in our layout, I don't know if anybody knows how Rails puts things together, but what we have is this thing called a layout, which basically gives it gives the HTML structure. It's in ERB, which just gets processed like any of those other things, ASP and whatnot. And then, of course, what happens in the middle is this yield bit, and so other little bits of HTML can get, or ERB can get put into here. So this sets up our page with all the JavaScript that we need for Cytoscape. In the show, which is if the method that this basically renders, we have our Cytoscape graph URL, our path to our flash images, just like in our tutorial. We have our Cytoscape graph URL, which is going to be able to get the data through JSON and then eventually draw in our options. And then it all goes into this section, which is what we named as the div into which to add the visualization. So what happens when the request is we go to our controller hits our request to get the show action. It has some default parameters, and the nice this will come up in a bit. Well, actually, I'm not going to be able to show it to you because I'm not on the VPN, so I'll just tell you right now. We have three general parameters for this for the data. Include awards, include studies, or include publications. Include publications is by default. And so for each one of these things, the parameters are either set to something or 0 to ignore those. We find our investigator, and then we set our backend JSON to the Cytoscape data URL for this member, sending in a bunch of the parameters, including the parameter to the investigator. Our callback is here. Member Cytoscape data is similar to member Cytoscape data URL, just matches, same name here. And so what this eventually does is it just renders JSON, either format. We have the schema that is needed for the data and the data, which is the generate Cytoscape data, which is going to be our generator, and returns the data schema and the data in a hash. The generator is right here. What we do here is simply this takes the investigator and some of the parameters. Basically, the parameters we need to know are, do we want the publications, awards, studies, or any combination of those? And then returns these array of hashes into this hash, which has nodes and edges, which is what we needed from the tutorial we learned. The publications, as you can see, are here. This is getting a little bit more about specific that matches what we need, but we'll see how that comes out. It's pretty not too bad. So similar to this, we have our test to show that these things are exactly what we need. So we have our generate Cytoscape data. which is an array of nodes and edges. We know that, so we asked for the cytoscape data. Basically what it takes is the investigator, the depth, and then either the publications, awards, or studies. This one, of course, we're just testing the default, which would be the publications, does not include the word studies. We should get the nodes, we should get edges, and we have we assert the publication edges, which are right here. This is the format that we learned from our tutorial of what the hash needs to have, and so we built up the information that we that is needed for the node and also for the edge, which is going to be the nodes are the endpoints, the edges are just the connectors. So you could actually see some of these things. The data that this is actually the data that comes back from that query: one depth, one publication, no awards for Warren. You can see that we set up the data schema initially, what the nodes have, what the edges look like, and then because this can be set up configured to what is needed for the array that's we're sending back to the bit, and then of course you can see the several associations that need to be done here on the node, on the data for nodes, and then of course on the data for edges is much further down. But this is the associations between these people. So 10 shared publications between Rex and Warren. You can see again right here, 10 publications between Rex and Warren. There it is. And then of course just all that is put together. The data setup for this, what we had here is for our test, we have two investigators, just one publication, study, and award, assuming that if there are more, it'll continue to work if it works for one. We set up the associations. We have some other information that is run in our background tasks that when we are building this data, we also set up associations through awards and studies. As I said here, PubMed Utilities was the thing that updates all the citation information, so just extra information for the investigator comes through this stuff. And then, of course, we have also in our mesh utilities, this builds our colleague based on certain who we worked with, either through how are they associated with us. So, yay. So that's the one graph. We also can do the same thing for the organizational unit. It is extremely similar, except for just where our focal point is on who are the associations. In this case, instead of Warren, our association starts with preventative medicine, and then of course how these people are work together. Again, the cytoscape controller. Similar to show org, basically the same thing, even shows the same, renders the same page. Only different here is the title, the thing in question, and the data callback URL, which ends up being, I'll just go back here, Ken, similar. It is actually the same, so I'm going to skip all these three. The callback, though, is here to the data endpoint, generates the same schema, but what here is we have a generator that just generates the organizational data for this bit. So in our generator here, again, similar needs nodes and edges, but in this case we generate some organizational nodes and some organizational edges, which we then confirm here in our tests. Set up a little bit differently so that the investigators are associated with the same organizational unit, and then we just assert the same publication nodes. They are the same at that point. We assert one organizational unit node and an organizational unit edge. So, and those similarly, publication node, here's the organizational unit node and edge. Same, because it's the same schema, it's going to be the same hash keys, but slightly different data. and then let the cytoscape control software deal with the rest of that. So this is for the organizational unit. Different identifiers here for this. I could do cytoscape radiograph number 3, but I can't because I'm on here. This was just going to show the association of just the awards, and so we do the same setup, same control, different data URL. So the callback for the JSON is the only thing that's different in this case. Am I going too fast? And I want to pause for questions and things, but I don't also want. Oh, so
you're doing great. Keep going.
All right. So great. So in the cytoscape controller, we also have the same thing for. We also use the D3 library. So let's look at the chord graph because everybody loves the chord graph. I actually love the chord graph. Here's Warren's chord graph. Again, it's similar information shown in a slightly different way of Warren's interactions through his publications. You can see that Simon is worked with several people that Warren has worked with, being actually the lead investigator at this point on these publications. I believe is from the matching color to the outgoing connector. I believe then in this case Varga is the lead investigator on lead author on this one associative thing. Also, you can see that in here there's only one person that Warren has done multiple publications with, and everybody else he has done single, and that's with Wang here. And you can see that is with a thicker connector. I wish it were a little bit thicker, but whatever. So what we do here again is, hey, I saw that somewhere. How do they do that? So we found we got this from Mike Bostock. Here's the chord diagram. Here is the HTML for the bit. As we can see here is we leave most everything to the D3 layout module JavaScript. This sets up the chord graph. What we really need to do here is provide this matrix of our associations. So here let's look at our cytoscape. Wait, this actually should be the D3 layout. I'm sorry. Okay. So here's our D3 layout. Again, setting up our JavaScripts. And then, of course, we have our yield again here. It yields to what investigator chord right there, to the investigator chord view here. And basically, this is some styling and the same JavaScript that you will see over in the chord diagram on Mike Bostock's page. A couple changes, but for the most part, this is what works, so this is what we use. The one big difference is the first part, this function that we have in the imports on the callback to build this matrix and the name by index hash in the matrix, which we will send eventually to the chord diagram. So here, we'll go look at what the action is on the controller. We have the investigator chord diagram, and we find the investigator, and with that identifier, have set up the URL to the D3 investigator chord JSON endpoint, which is right here. And gosh, you can see a similar pattern. We find our investigator, and then create a graph through one of our generators. The D3, oh, here's the actual data at the end point here. Notice this has nothing to do, this doesn't look anything at all like the matrix that is required by the chord graph at this point, but that's where we massage it in the JavaScript. Our generator here creates the graph. We find all of the investigator co-authors, their colleagues, and then we add each one to the graph through the investigator and their co-authors. Loop through, loop through, loop through, and then we keep adding to the investigator graph here, which is, sorry, here's the investigator graph, another hash, simply in a different thing where we have the name, size, and imports. Imports is just all of your co-authors, which should be right here. I did everything correctly. Yeah, so all of your colleague co-authors we keep throwing in there. And we associate them by last name, which works so well because you know that no investigator is ever going to work with somebody that has the same last name. It is awesome. So what happens here is this, I put a little gist of what actually happens through the in the JSON to create the matrix as something to show for you guys. So as you saw earlier, this is the data, the imports that comes in. So when we actually go to the chord graph here, I'm going to switch to Firebug, and if we want here, console, paste that crap. We run in here, and so we set up the variable matrix here. Through each import, we find the person by their name, and then find them through other imports, and then generate this graph of people. First line is Warren, so obviously Warren has never worked with himself, but he is going to at least have one publication with absolutely everybody on here because this is him. And as I said, remember, there was only one person that he's worked with more than once. So that is how we build. Oops, sorry. That's how we build that data for this graph. Specs for that are here. We have the D3 master investigator graph. Basically, when we call this for an investigator, I should have a graph with associations. It's an array. And since we know that there's one investigator and one co-author, we have our PI, we have our co-author, and this is the inverse of that association there. The investigator graph itself is right here. Again, name, size, and imports, like I was saying. Imports, you can see down here is what this actually looks like here. This is the co-authorship associations, and you can see that it's just going to be an array of the same graph. Our data setup for these, it's basically the same as the other two together. Basically, we have our investigators. We have, in this case, we wanted a hierarchy of organizational units, so that we have a school and two sub-departments of the school. Each investigator is associated with one of the two departments. I grabbed somebody's abstract in order to make some, give me some words that look cool for my Wordle test, and then we have we put the words in the publication, and then we also create a proposal and an award and a study, and then set up the information similarly to how we do in our background tasks that happen. Again, you can see that the citation information and investigator colleague are similar as before. One here, though, we have a new thing in order to get those organizational abstracts, the ones that are associated with the org unit for that. Our utilities here, what is this going to show us? Oh, this shows how the update of the organization abstract happens. So we just have this organization abstract record. Chord graph. We can do the same thing again for an organizational unit. I won't go through this one as much because it's basically the same thing as the previous one. Difference being is, again, who is the person in question. And those are very similar bits here for the test. But of course, as with anything, the data endpoint is different. So we have tests for output for the entire school because of the subdirectories, and then of course the other one per department. And I'm going to show one last one because this one is, for some reason, my Don's favorite one. We use the Wordle a lot. This is Warren's word abstract, things that he often uses in Warren's publications. This one comes from, D3 is really nice because it has a lot of other associative people working on this. So this is Jason Davies' word cloud example. And here we can see that we have our layout, again, our cloud. Here's our words, and then we draw our words in the layout here. So I don't know if, ooh, this one's not going to actually work. Sorry, this should be, oh no, it's just in the wrong name. So here's the investigator Wordle. You can see why I said it was going to be a miss. There was chord right there. But here's the Wordle file. And as you can see, very similar to our simple HTML from Jason Davies. Thank you, Jason. Shout out to you. We do very much the same bit in drawing out the words to our D3 cloud layout. Only basic difference is that we map the words that we get through this function, the JSON callback. These are the words that we have to use. So, similar to, again in structure, to we have our controller. We find our user, if we can, and set our title and JSON callback to the D3 investigator Wordle data for this investigator, which is right here. We find our investigator with our parameter, and then just have these two little functions in that word frequency model I was telling you about earlier, the one that basically only exists in order to build this graph. The Wordle data at the end is here. We have, you know, a whole bunch of words that Warren has written. The generator for that is here. We have a frequency map for all of the investigators' abstracts words. Those are things that obviously we have set in the database in the backend during one of our bits. And then, of course, we'll emit some high-frequency words because the would be a really bad thing to show up on the, in one of these graphs. Again, here's the frequency map. Builds this hash with the word and how many times that word is used. As you can see from there, most of them are through abstracts. We also have things that we use some data also from the School of Medicine database on people's interests and things. So it's not just words that are used in publications, especially for young investigators. That's probably good. And then the Wordle distribution, yeah, it's math. So how does this one get generated? We have to, again, in our background tasks, we set up some data that is run in terms of frequency, and then we are able to grab that information for the data. In our test, all we are doing is saying that there's a word. It's there once because we only set up one abstract, and obviously there's no other type of data we're getting from, so that's why it's abstract. And more data setup here is the setup there that happens. Leave that to you for your nighttime reading. Okay, gosh, that was all of my things. The ones that I wanted to show you because I thought that would be enough time and plenty. Couple of things we've learned. This one's not actually going to show very much, but some of the visualizations we have, interesting to play around with, but something, oh gosh. When you can see a lot of the award publication and study data for an organizational unit that's pretty large, basically the connectors get to become one big black circle. So there's nothing actually that you can actually see between the two there. Understanding that. The data setup is very important. Here is our, these are what we run weekly in a cron job. Something to insert, get new abstracts, update the associations, co-authors, stuff. And then the other really important thing is after this import, we touch every page. I was trying to point out earlier about in all of our controllers, all of those caches page. Basically, after we import everything, we touch everything so that everything that's possibly cacheable is cacheable. Unfortunately, recently, now that this has been running for 5-6 years now, we have a large amount of data. We've had to actually limit the things we actually cache because some of the pages now actually will take down our server. There are a couple of organizational to organizational relationships that basically will crash us, and so we're starting to work through that.
Do you see any of that with your deep visualizations?
I don't remember which one it was. No, I don't think anything there was that large that we worked with. But it's something that we're obviously going to keep an eye out for. But that was we were wondering why our import process wasn't running for 4 months and why it kept crashing. And then we finally figured it out and made a couple of changes. Oh, and so last part, thanks. And I guess I should have said I'm open for questions.
Well, Paul, you did a fantastic job. That was. I loved how you went into the code as well as showed the examples. So we're open for questions.
Maybe I'm gonna just jump in actually. Sorry, because when I started working with VIVO and with my understanding of Lattice Grid, and this is what I really wanted to try and show you guys out here, was that for the most part, a lot of our other than getting the data together, the UI stuffs are really simple, but the data endpoints were the things that were the only thing that changes. And so I was just thinking that in some way, either getting the data endpoint from VIVO or some sort of data endpoint from VIVO that could be massaged through the generators that we have or whatnot, or something similar. The whole process can keep, I'm thinking about hoping to port everything over.
I think that would be possible. I mean, the trick that we've been messing with down here is what you seem to have solved, which is how to do the caching. Is thinking about what are the right ways to massage the data at what interval, and at how much to trim off so that you could get it into JSON and get it into the visualization.
And that's exactly why we have some points where we have some data that comes in and then is massaged on the front end in the JSON or in the JavaScript, or can we just output the necessary data that the visualization needs?
Hey, Paul, this is Jim. Just wondering, are you caching data streams themselves, or are you caching HTML pages?
Some of both. Not all. Not many of the JSON endpoints that I've shown. But with graph viz, for instance, what actually is the data endpoint is an SVG output that we cache on in the file system. So for some of the things we've basically the rule of thumb is we cache what we can cache, and if it's data, that's great. Yeah.
Okay, thanks.
Well, Paul, this is Lane.
Hi, Lane.
Hi. Since there aren't other questions, or maybe there are questions, but I'd like to ask one. So we have the issue with VIVO right now with visualizations and how we map different institutions that use VIVO, and you know, people always get turned on by visualizations, so we need to fix the problem of, you know, mapping different VIVO institutions. From what you've shown us today, you know, excuse my ignorance, but from what you've shown us today, are any of the tools that you're using tools that could be utilized to help us to potentially solve that problem if we have the correct data to work with?
Yes, I think these, yeah, we've only touched on I mean, even with having started with ProtoViz and D3, we've only touched on the surface a lot of the things that are out there that are available. Mostly, this was Warren's playground for things that he was able to find, and he was very infectious about trying to say, hey, see if you can make that. So it's been really great working with him to do those things. So I can't see that. I think that everything that we've used is open and available for VIVO. I guess I would say that from what I've noticed is that the trends, obviously, have gone towards just pure JavaScript and HTML5.
Okay.
For all those things. So a suggestion would just stick with those libraries.
Okay. Well, there are minds greater than mine that are on this call that you know, can better understand how this could be utilized, and I'm looking forward to talking more with you at the hackathon.
I'm looking forward to being there too, and seeing the hundreds of waterfalls.
Yeah, but thank you so much. You did an absolutely super job of going through this. It was a really very good presentation.
Yeah, I'll try and I'm sorry I didn't actually realize that I wasn't going to be able to show the awards and study data, and I asked Warren if I could use his stuff, so maybe I'll get some screenshots and send those out to you folks to see that type of information. How I really wanted to show you guys the blob of nothingness. All right. There's something else on the okay, discussion of VIVO data. Oh yes, that's what we're doing.
So it's 2 o'clock, so people should feel free to depart, and I want to again thank Paul for putting this all together, and I too look forward to hearing more about this.
Great, thanks, Ted. going to lunch.
Thanks, everyone. Thanks.
Have a lovely day, all.